simulation workflows grow more complex, manual repetition quickly becomes a bottleneck. What you're seeing here is the automation of the IS-374 air delivery test for ceiling fans using PyFluent, ANSYS Fluent's Python-based automation interface. At the beginning of the workflow, the fan geometry and computational domain are imported. Instead of manually defining settings through the GUI, PyFluent scripts are used to automatically set up the model, ensuring the same configuration is applied every time. Here, the simulation parameters are being defined. This includes boundary conditions, rotational speeds, airflow regions, and physical models required for IS-374 compliance. By scripting these steps, the setup remains consistent across different blade designs. As the video progresses, you'll notice the simulation being launched directly through the Python workflow. This allows multiple design variants, such as changes in blade angle or geometry, to be evaluated without rebuilding the model from scratch. Once the solver starts, PyFluent manages the execution process automatically. The simulation runs, monitors convergence, and proceeds without manual intervention, reducing setup errors and saving valuable engineering time. Next, post-processing is triggered through the same automated workflow. Key performance metrics such as airflow distribution, velocity contours, and air delivery values are extracted systematically. Rather than manually inspecting results for each case, PyFluent enables repeatable data extraction, making comparisons across designs faster and more reliable. What this entire workflow demonstrates is a shift from manual, repetitive simulation tasks to scalable, script-driven simulation pipelines. With automated IS-374 workflows, engineers reduce manual setup time and focus on improving air delivery performance.